What is a multi-component system? It's a system that has two or more species, and the interactions are between the first component, the second component, and between them. What happens with equilibrium in a two-phase system? Each component has the same fugacity in every phase. If we have the simplest system, liquid vapor, the fugacity in vapor phase equals the fugacity in liquid phase. How the fugacity in the vapor phase is calculated? With the ideal gas law, which is a reference state that is the ideal gas. We substitute the volume in terms of pressure and we solve for fugacity. We know that reference state is at high temperatures and low pressures.
What about the fugacity in liquids? In the case of liquids, we need to choose a reference state which is an ideal solution. That means that all the properties are going to be additive and the molecules will have the same nature and size, so the intermolecular forces will be equal. How the fugacity is mathematically expressed? The fugacity of the component I in the liquid phase is equal to its composition times the ideal fugacity of the component, considering it as a pure species.
How the ideal fugacity is calculated? First, we have the Lewis-Randall reference state, which is for condensable components. The solute represents the majority of the solution. Therefore, the composition of A tends to 1 and we have AA interactions. Here we have the second reference state, the Henry's law. It's for uncondensable components. Here the solute is very diluted and the composition of A tends to 0. We have interactions between the component A and B. It's useful for dissolved gases. What if the mixture is non-ideal? Well, then we have the activity coefficient, that is a term that corrects the deviation of the mixture from the ideality. If it's 1, we can assume ideality in the system, and it's possible to get the Raoult's law.
Created using Powtoon.